All right, if we can get started. All right, welcome everybody. We are now at the next section that we have out there, and I've got to move my thing up here a little bit. So we're now doing Do More with Change, introducing Couchbase eventing. This is an awesome presentation. I know I've seen parts of this before. We have Venkat Subramanian, who is going to walk us through and try and make us work, and he's one of our directors of product management, which has been fantastic to have working here and be with us. I hope everybody enjoys the session, and Venkat, just take it over.
Thanks a lot, Art. Great to be here. Just a quick show of hands. How many of you are new to Couchbase? Awesome. So what are we trying to do here? Couchbase Eventing Service is the name of the service, and we are planning to launch a few things. What exactly is Couchbase Eventing Service? And I'll give you an overview, spend a lot of time with the demos, and show you some of the architectural deep dives of how things work. Having said that, a quick story. So this guy, actually, he's working on something. Okay. Suddenly, he just gets out of his place. Someone asks him what time it is, and it says 1:15, and he says thanks. He opens the refrigerator, but he kind of forgets what exactly he was doing. Okay, this is a simple comic strip, but this is a nice book. It's called as the 99 Ways to Tell a Story: Exercises in Style by Matt Madden. And what he does is he takes a single, this what I just narrated, and conveys it in 99 or 100 different strips. Okay, the same plot. And so here we are seeing just the thought clouds, what's being exchanged, just the silhouette of what exactly is happening, and just a single strip which actually captures everything, right? Why is that I'm showing this? The idea is the same single story, but the styles are very different. And that's exactly what Couchbase Data Platform gives you. We store data, but the way you access with data is very different. You can work with GSI, you can do bucket ops, simple key value operations, nickel GSI, full text search as you saw earlier. Analytics will be coming up later with eventing. And that's what I'm going to be talking about in the subsequent, for the next session, essentially what eventing does. It's also an access pattern. Okay. So let's say you're working, you're storing data with your Couchbase as such, and you want to get notified when something changes. Let's say there's a create, update, or a delete that happens. You want to get notified. There's a certain attribute that changes, and based on that particular, let's say you're storing patient information, and when the cholesterol level goes above beyond a particular point, you want to do something else, right? You want to propagate this change to some other system. You want to do all these things in near real time. You don't want to do a batch system as such, right? And also, let's say the idea of timers. You want to trigger off certain things at specific intervals of time. And we are a NoSQL database. We don't have referential integrity. So if you want to do cascade deletes, how do you do cascade deletes, right? Many of these things are, if you see the nature of the workloads, are highly asynchronous in nature. You don't have to do it, you don't have to block your writes. They're extremely low latency applications. These would run probably in less than a second most of the times. These are easy to parallelize, and these are business logics, right? This is not technical requirements. These are business logic that will keep changing based on the way your business is defined. And most of these don't have a local state, And based on seasonality, how do you actually apportion this kind of a traffic? How do you create a system which actually does all these things? Right? So how do you solve this kind of a problem in the current scheme of things? Let's say we do not have Couchbase eventing. How do you solve it today? So applications continue to write to Couchbase, right? They cause a change. When I say change, it's essentially any create, update, or delete happens, right? And many of these applications would write to a message queue or enterprise server bus, right? Many of you might probably be doing this. Most customers probably do this once they are ready to invest in the message queue or a bus. Not a bad, I'm not going to critique these, but there are certain cons to it. Essentially, you're introducing a new layer, right? There's a dual write problem. You're writing from two different places. You have to introduce transaction semantics into the application, because what happens if it writes to Couchbase and it fails into the message queue? It's a pain as a developer, right? And if something fails, how do you take care of failure aspects? Do you go to the transport? Do you go to the message queue? Where do you go and debug? Painful. Manageability, data governance, because there's going to be data leakage. You're going to be writing at multiple places. There's a data leakage problem. And because of all these things, if you see, TCO is not just the license cost, right? Your deployment models, all these kinds of things are interrupting your workflow. That's one processing model. The second one, what you would do otherwise. So applications continue to do what they do, right? Let's say you have two different applications. They keep polling for changes, right? This has been there for decades, right? For 3-4 decades, polling has been around. But this works out well when the amount of data and also the frequency of the batch system is not very high. It's there are certain problems, right? Essentially, it's inefficient. It's highly inefficient. Batch systems waste CPU resources. It's not reactive. You continue to poll for changes even when there is no change. There's code duplication. So the way you manage the infrastructure across these two polling apps is painful. And if something, if you want to scale, let's say on a Black Day, Cyber Monday or something, where do you actually scale? Do you scale the application? Do you scale the transport? In our case, Couchbase scales pretty well, but what do you do otherwise? So these are the two probable processing models that most customers use. Most of you would agree with this, or probably doing either of these. Yes or no? Yeah. So the idea was this, so given the cons of these, can we do better? So when the source is Couchbase, when you're storing at Couchbase, can you do something better with this? And that's where the idea was, as a developer, you focus on business logic and not on configuration or infrastructure. And this is not a marketing pitch, by the way. We really mean this in the product. And we espouse this product philosophy, and we have created systems which actually follow this ideology. So what exactly is eventing service? It's event condition action model, as you would have heard it in the keynote today. An event happens, a condition is checked, and an action is triggered. The condition could be a business logic as well, or even otherwise. Mostly it's stateless compute for extremely low latency workloads. Most of these workloads runs for less than a second. You don't want to do something like an image processing in this, right? Okay, the third thing is, again, a product philosophy. As a product manager, I kind of make sure that this is espoused in the product again. Easy to use for your developers, easy to manage for your administrators, and most importantly, your customers. They need to be really, really performant, right? So your engagements have to be really, really quick. And if you saw in the polling model, many of these were batch systems. It was query. So unless you go and query for certain change, you don't know what's happening. Let's say you have in your organization, you have to keep querying your boss to know what's happening in the system. It's not effective. Rather, if your boss says, hey, this is what is going to change, it's much more effective. So that's exactly what eventing espouses. And I used to manage GSI, Global Secondary Indexes, earlier. So in GSI, we released a new storage engine called Plasma in the last 5.0 release. We did amazing innovations with the way we manage memory, okay, the way spillover happens. In this, it's all compute-based workloads. So we've done some amazing improvements in the way we use the multi-core CPUs. So it's not just the software aspects of it, but also the hardware. So eventing service is the high-level framework. We plan to launch multiple products. In that, Couchbase Functions is the first offering that we're looking at in 5.5, which is going to happen by the end of this. The beta is already out. So what I'm going to show you, everything is there in the product as of today. You can download the binary from the website, and you can start playing around with it. So what Couchbase Function means. A document is created or updated. You have an on-update clause that gets triggered. You can have multiple on-update clauses that gets triggered, right? One is too many. Similarly, when there is a delete, on-delete clause gets triggered. That's about it. We want to make it as simple as possible, and we think it's a pretty strong thing in abstraction. Having said that, many of you who have been using Couchbase, if you're using KV, if you're using GSI, if you're using any of the offerings as such, you're essentially using something called as DCP. So what happens is when data is stored in Couchbase, we create something called as a database change protocol, which actually captures all the changes that are happening. And this actually is being used when the data is replicated in XDCR, in GSI, views, FTS, name it. With eventing, we are productizing this offering, right? So at a high level, does it sound like a post-action trigger in the database world? Yeah, kind of yes, kind of not. This is a triggerfish, by the way. It's I kind of started doing some scuba of late, and I kind of like the analogy of a triggerfish. I did not want to show something else which was controversial, which you would know. But yeah, so post-action trigger. But if you remember, triggers suffered from two main problems. One was scalability. You could never independently scale triggers. The second was diagnosability. You never knew what was happening inside the trigger. If you had to manually know what is happening, you had to have a temp table. You had to keep on inserting as a pragma autonomous transaction inside this. That's exactly how I started my career as well. So luckily, Couchbase comes to rescue here. We have something called as an MDS, multidimensional scaling, similar to DCP, which is our secret sauce. MDS helps us solve some of the important problems. This gives us the ability to launch services like eventing. You can independently scale. So the two primary takeaways of MDS is workload isolation. Let's say you are having indexing. So most of our customers actually keep each of these services in a different set of nodes, so that they can scale up and scale down independently. With eventing, it's compute-based workload. You don't need to have a box which has huge memories. Whereas GSI, you need to have probably higher RAM boxes, right? So Workload isolation is important, and independent scalability is what is given with MDS. Having said that, demos is what is fun. So I'm going to attempt some live demos. So I have a few buckets, actually, and ignore the logs one, that was a backup, but essentially most of the buckets have nothing. What I'm going to do is, the way you would create a function is, so this is the 5.5 beta build. This is the console you'll be seeing. The way you add a function is just go ahead, add a function. You always listen to one source bucket. The function listens to one source bucket at a time, okay? You choose a thing, the logs here. And since this is the V1 of the product, we store some checkpoint information which needs to be stored in some place. So you need to apportion one bucket for this case. We ideally recommend that you don't put anything else into this bucket, call it as metadata bucket. And in this schematic will change in the due course. We are starting off with the metadata bucket, but it will go on to something else. So test, description, and you remember what I told you about minimal configuration, right? So we just have three things that are exposed. The log levels, workers gives you the scalability aspects. So as an administrator, when you're deploying across different boxes, you can scale up and scale down the number of workers, essentially the number of cores that are mapped. And script timeout. It's essentially when you're doing something like a serverless idea here, you want to have a timeout after which the function should time out as such. I'll be talking about it a little bit more. So when you're working with these kind of things, in the WebLogic world or in the application layer, when you're deploying a WAR file, you would probably put a lot of code inside the code or in some configuration files which are extremely environment specific, right? In our case, it can so happen that you call the same bucket, different things probably, bucket dev, bucket stage, bucket UAT, and bucket in different environments. Your code should not change. As a developer, what you need to write is good quality code. Administrators should be able to define which bucket it goes into. So that's what binding gives you. We have this idea of a type, which is an alias. This is the number of buckets that you can create an alias for. You just specify something like an alias. This is the SRC is the name of the variable name. Can all of you see at the back? I'm sorry, I can't take it. But essentially what I'm doing is I'm creating an alias, which is a variable name for the particular bucket. So I'm calling SRC is the variable name for the user's alias. And that's about it. So if you see, I chose the bucket, gave some function names, description, minimal configuration, bindings. Voila, that's it. What you see is you just start coding here. So you get the on-update and on-delete function handlers. And this is where the code goes in. So, but let me show you a realistic use case of what exactly we could do, right? So what I'm going to do is I have certain, we'll do a credit card transaction realistic demo, okay? So you have a user's profile. For every user, you have multiple transactions. And how easily you can develop things. Does that sound like a good use case, right? So what I'm going to do is I'm going to load few users, 6 users. I'm not going to show the scalability aspects of it because I'm running it from my box, but we have tested it at multi-million, billion transactions, and it kind of works pretty well. I'm inserting few transactions. So if you go and look at the bucket, and it's all kind of realistic documents. So if you look at the users, I'm capturing the name, the demography of the particular user, annual income, credit limit, locality, zip codes, whatnot, okay? So it's a kind of a realistic document. And the transaction, so this is probably every swipe that you do with the credit card. It captures the credit card amount, the currency, description, the purchase mode, the postal code. So example, if you want to make sure that the swipe of the transaction matches with the home currency of the user, how you want to do it. So the data set is ready. What do you want to do? So I showed you how you actually create a function. Luckily, we have something called as import here, right? I can import a function. And what I'm going to do is I need to find out. So when I import, automatically all the values are pre-filled. You can import and export. So you have T2P, P2P use cases, right? Test to production, test to test, different environments. Essentially, you want to port code across different environments. So that's what import export lets you do. Everything is pre-filled. I just say add code. And let me come back to the code in a minute, but I'll go ahead and deploy it. And I'll talk about a few things in the due course. So when the code is, let me go ahead and show you. So essentially, this onUpdate clause will be triggered for every user, every transaction that happens, right, for the transaction bucket. It checks whether the credit limit of the user is lesser than the transaction that is swiped. So if the credit limit is $1,000, but the swipe is for 10,000, it's a high-value transaction. It's a high-risk transaction. So essentially, when you do credit card scoring, you have multiple layers of scoring rules. You'll have something which you need to score immediately, which can be done in a batch job or in near real time, right? So you can do all these things. So this is high-risk transactions, which are just checking for few attributes, and immediately you are pushing it to a different bucket. So what I'm doing here is checking that value, and I'm enriching the document with comments. I'm saying that, hey, this is a high-value transaction because credit limit is higher than, the transaction amount is greater than the higher limit. I have a reason code, and I put it into a different bucket. So all the flag transactions will be put into a different bucket. Make sense? Yep. And I similarly check for the currency. If the transaction currency is not the same as the home currency of the user, immediately flag it. Okay, so in the time that I actually deployed it, I'm hopeful that, see, already the flag transactions, you see certain documents, and the value is there. Let me just go ahead and see how many of them were actually flagged. So XC mismatch, the currency mismatch is around 11 transactions with an impact of $57,000 and credit limit of around $20,000, right? Which you can see from the nickel console. Idea is how easy it is, right? Just to enforce certain things. So let's say now your business logic changes. You just have one place where you go and edit it. You don't have to go scrounging around your environment, to see who is working with this. Makes easy. Now let's say the referential integrity, cascade deletes. How do you do that? So I'll show you that example as well. So what we'll do is, let's say when in this kind of a system, a user can have multiple thousands of transactions. Right? When the user is deleted, all the transactions also need to be deleted because I'm pretty sure you have a backup database wherein you keep all this, the master records. So the code for that is also I'm just importing it. It's pretty simple. You need to call it only when on delete, right? So that's why onUpdate is nothing there. So it checks. It's a simple business. I just put it as if its ID is less than 10, only then you trigger it. And it deletes all the dependent transactions from this. So if you see this is an actual nickel statement that you're firing here, right? Delete from transactions wherein user ID is this user ID. Make sense? I'd go ahead and deploy this. Okay. So while I'm deploying, I need to talk about a few things that are important here. So when you start consuming this, and it's also a big differentiator for us, when you deploy this, you see the screen, right? So when you start consuming this kind of change feed, based on your business rule, you might say that, hey, I want to consume all the changes from the beginning of time, right? Or this is a new business rule. I want to start consuming it only from the changes that are happening after this deployment, right? Let's say you're starting a campaign wherein you want to start doing after Black Monday. So you don't want to consume all the changes that have been happening to your Couchbase cluster before that. So that's what this feed boundary gives you. So you'll be seeing everything or from now. And you can choose how you want to consume the change feed, right? So when you're talking about all these things, you remember the diagnosability aspects. I told you about, let me zoom this a little. So I told you about the problems with triggers, right? Diagnosability and scalability. Scalability we take care of, but diagnosability, if something is happening, how do I know what's happening with the the function? So if you look at the code, actually, I put in some log statements. There's a log here. You see this? I can pass on a string. So what we do is we create application-specific log files on the file system. So which actually captures, you can put whatever you want. In some cases, if you don't want to do any bucket ops, but just keep dumping everything into the log, this is one of the best ways to do it. Just create a log statement and everything. And this is a log file that is created per application. It does not contain any system level information of your rebalances that are happening or anything else. This is something which you control. You will be specifying what goes into this application log file, right? That's number one of the diagnosability aspect. There's a second part to it. So let me go ahead and actually show you how that cascade delete works. So I have around, for every user, I have close to this amount of transactions in the first columns that you see. So essentially for the user ID 2, there are 5 records. I'll go ahead and delete the second user with this user ID 2. right? So if I go to the query, so you remember this, I'm just going to execute it now. The 2 is gone. You didn't have to do anything. It's just at one place. Make sense? Pretty easy? Okay, let me complicate. So I showed you cascade deletes and a very simple use case of how you do selective enrichment and putting it to a different bucket. Okay. There's something interesting that we can do even better. So let's say, how many DBAs in the room? Any database administrators? Yeah. So often it happens that when you have a NoSQL system, your developers keep on adding attributes to your document, and they just keep playing with it, right? And you have no freaking way of actually controlling who is adding what, or do you want to get notified if someone actually deploys something. So what I've done is it's a simple code. You can literally take this code and run it in your beta cluster. So what it does is it checks for all the valid keys that are present in the document. And if there is anything that does not match this valid set of keys, it puts it to a different bucket. As simple as that. So for your audit thing is solved, and you can literally take this code and make it run in like less than 10 seconds. So that was the use case, but let's go and see. It has already run probably. Okay, so far I'm just logging all the documents that are coming in. There's no failures. But there's something interesting happening here. So you remember the diagnosability aspects? I just showed you one aspect of it, the log. At the bottom of the screen, you can see a debug button. Why is that? What is debug? So let's go and click debug. So when I click debug, it says waiting for a mutation, right? Nothing is happening. So because there's no updates that are happening to the Couchbase cluster, right? So what I will do is I'll go and trigger a change. And I will add Venkat to connect NY. Okay? I've not saved it yet. I'm going to save it. Let's go back to this window. And I get this URL filled. What do you think is going to happen next? Any guesses? With what? So what we have done is we have integrated the Chrome debugger with this. So I think this is one of first of its kind wherein you can actually debug a mutation in real time. You can step through this. You can put breakpoints. Yeah, you see everything. So I'm sure most of you would have used a Chrome debugger. What we have done is we have taken that from what you would be using for a website to actually a data operation. Sounds good? Is it okay? Yeah, so. Sorry? Good question. I'll take the questions at the end. Yeah, I'll take the questions at the end. But just to quickly answer, we understand V8 runtime really well. Our views runs on V8. So as of now, we only support JavaScript. Yeah. So you stop debugging, and that's pretty much about it, right? So how are we doing on time? A few minutes more? Or wrap up? Okay. So that's exactly, you could literally create functions and get started with what you're storing actually in absolute no time, right? That was the basic idea. Sorry about that. So we saw the language constructs in terms of what is possible, restartability semantics, feed boundaries, V8 optimization. So one of the things that we have done is, since we understand V8 well, if you're doing kind of nested queries, when you do a for loop of a nickel statement, we do a streaming iterator. Okay, so if you should not be doing this in any production thing, because if your query is getting 10 million records, that's a bad query. But assuming that if you do something like this, we kind of take care, your cluster will not bonk. Yeah. One quick question on ordering, because this keeps coming up. So just a detail of the implementation. Essentially what happens is, let's say you have 3 data nodes. The bucket is automatically partitioned across V buckets. And let's say you have one eventing node with one function with 4 workers going on. Each of the workers will get divided by 4 partitions assigned to it. So all the V buckets will go to that particular worker. So if you keep adding more functions, it automatically gets divided by 3. So in this case, I have one more function with 3 workers, 1024 divided by 3. Now the question is, what happens if I add one more eventing node? So because the load on the system increases, so it just keeps dividing by 2 That's about it. So the worker assignments keep changing as such. So remember the three things, whatever we are showing you is essentially to improve your customer experience, do things really, really fast. And this is the first release, and as a product manager, I'm pretty excited that some of the customers have actually started using some really good, interesting stuff with it, some gaming customers. The feedback is amazing. I'm not able to put a name because the referencing thing is going on, but hopefully I'll be able to show you some names in the due course. I'm pretty excited about what's possible, and remember that we are just taking a baby step here. If you're going to consume a DCP, so the one in yellow at the bottom was kind of interesting because we heard it really, really long time back, like last August when we showed this. They were trying to consume DCP directly, but I think this abstraction is much better. As I said, this is the very first version of the product. Even though what you're saying, you could do a lot more, we are kind of humble enough to understand that this is just the baby step. The future roadmap is pretty aggressive in terms of what is possible. There are a few things that you can do very easily. There are a few things you should not be doing. And I'm there to help you guys to succeed with this. That's pretty much about it. So it's a platform that we have, and the use case is what we had in mind earlier, and how customers are actually using it is blowing my mind out. I'm open for questions.
Up for Q&A. Any questions? I'm in the back. So is there any questions in the back first? No. There we go. There's always one.
Yeah.
Thank you.
Okay, I understand this is going to be a feature of 5.5,
Yep.
right? Any chance we can add eventing node to 5.1 cluster
Very good question.
and use the 5.5?
So best way is XDCR. Have a 5.5 cluster, spin it up, XDCR your existing buckets to a 5.5 cluster. You can get started in no time, like today.
Other questions? There we go. This is the best row for questions, I have to say.
Any suggestions in terms of using the eventing framework to do things like pre-computing, like daily counts and sums?
So that's something that we're actually working towards. As of now, you can do it. The problem is when you have distributed compute, it's essentially based on the mutation rate that you have. The problem is if you keep, let's say you're doing a group by using a nickel and you're updating it, or let's say even if you're doing a simple counter, let's say you have a bucket with a single document which keeps on incrementing. Let's say you have multiple workers that are updating the same thing. I've seen this personally. Let's say there are 500 updates that are happening. You'll always see less than 500 that happens because there's quite a lot of override that happens. So, but having said that, this is part of the roadmap, and we are actually working towards it. So what you see in 5.5, how many of you use Nickel? So in Nickel, we have done some amazing work with the way aggregations work in 5.5. So if you're using group by, the performance compared to the last versions is amazing, but that's just the first baby step. You have a very good V8 engine here. What we plan to do is we plan to actually move some of the views aspects of things when you are doing aggregations over here. So some of the use cases that you're talking about exactly will be solved in this particular problem with the same ideology of making things easy.
Thank you. Other questions? Oh, there we go.
Yeah, one question I have is if, like, coming from a relational database perspective, a lot of times we use ORMs. And the higher level abstraction that you guys have on the nickel as opposed to using the raw nickel, does it have all of the features that nickel has within the abstraction, or do you?
In this?
When you're developing software and connecting to the Couchbase.
From
clusters.
eventing, inside eventing.
Not inside eventing, outside eventing. It's a nickel question, really, not really.
I can get you over to Keyshop, who's the
Okay.
product manager for that. We can
Yep.
get you the right answer for you. Okay?
Any other questions? Essentially, I'm not showing you the demo, but you could also fire nickel queries. If I had time, I would have shown you wherein there's a second level risk scoring. If you want to run an ML model or anything, essentially you could do that as well. And you could, in this case, I'm just computing something like a group by aggregation, and yeah, it just checks on a daily basis what's happening. So this is also a timer use case. You actually create a doc timer, and it gets triggered. So let's say you want to get notified before an expiry happens. You can create, let's say, the document expiry happens at 12 o'clock. 2 minutes before expiry, you want to do something. So you create a doc timer, and it'll take care of things. So the doc timer semantics are, it also runs inside the same V8 console, but you can't debug.
Question. Can you show me the buckets for me?
Sure. What's the question, Bud?
The question is like the metadata bucket you created, right? It will be an identical image of the source bucket, whatever you configure?
No, so metadata bucket, actually, we store some checkpoint information. So since we do distributed compute, and we don't have any other place to store the checkpoint information, so essentially what a checkpoint is, the workers, it has to consume the feed boundaries, right, the feeds. So till what sequence number has the worker actually consumed the feed? So that information goes into this. And we generally recommend you not to touch this metadata bucket, because we plan to migrate this away in the subsequent releases when we have a better abstraction. This will go away into something else. But metadata bucket, for you, don't worry about it. Just don't insert records into this.
Okay.
How does metadata work in
Yeah.
So in XDCR, so the question was, how does metadata work in XDCR setup? So you have to remember that, let me take a step back. The function works only on this cluster. It does not work on the other XDCR cluster. You have to manually export this JSON and put it into a different cluster for it to make it work. Metadata bucket, I don't think you should be XDCRing it. If you're doing it, then I need to keep my resume ready. Yeah.
Other questions? Venkat, that was tremendous. Excellent. Thank you very much. We really appreciate it. Excellent job.